Hi, my name is Sumitra Mukherjee and I'm a Senior Technical Leader for ACI Incubation Team in Services of CISCO System. Today we are going to be discussing step-by-step install for the ACI Virtual Edge Switch. The ACI Virtual Edge Switch, also known as the AVE or AVE for short, is a distributed virtual switch that goes on a hypervisor. This presentation and demo will consist of two sections. In section 1, we are going to start off with an overview of the AVE. This is not an in-depth training for AVE, but goes through all the basic requirements that you need to know to be able to install and use the AVE. To install AVE on ESXi hypervisors, we will use the ACI plugin. The ACI plugin for vCenter is a plugin that goes on vCenter and shows you an icon for ACI in vCenter. Using this plugin, you could configure ACI objects like tenants, VRFs, BDs, EPGs, and everything else. However, for this presentation, we are not going to be doing that. The main reason for installing ACI plugin would be to install the AVEs on every hypervisor very easily. The ACI plugin can also be installed by the manual method by hypervisor to hypervisor, or also by using vSum or vSphere Upgrade Manager. However, it's easiest to use the ACI plugin install to install AVE on every hypervisor. To use ACI plugin, we first need to have a web server which we will use to install the ACI plugin on vCenter. There will be a Python script that comes with the download that needs to be run to make this happen. However, there are certain requirements for that VM. In this demo, we are going to go step by step and build the VM that will be able to install ACI plugin in vCenter. We are also going to mount a NFS volume that we will create in CentOS. This is optional. What this would help us do is to mount a shared storage from every hypervisor. We will then use the content library which is available from vSphere 6.0. The content library will need a volume to mount. This is the volume that we will mount in the content library. Then we will download the AVE OVF in that content library, and that content library will be able to reach all the hypervisors and be able to download AVE at one time. Once we are done with that, we are going to move on to section 2. In section 2, we are going to do a basic VMM domain setup, which is no different from the VMM domain setup that you do currently with ACI. This will push a DVS switch in vCenter. This DVS switch will have a few port groups that will be automatically configured. One of them will be the outside port group, another one the inside port group. The outside and inside port group will be promiscuous port groups of a PVLAN setup. PVLAN as in private VLAN. There will also be some other port groups like the infra port group and the quarantine port group, just like you see in the VMM integration currently. Once this DVS is pushed down to vCenter, we are going to connect up the uplinks to the outside port group. The outside port group will only have the infra VLAN pushed down to it. ACI will use OffFlex to push down a VTEP to the AVE. Then there will be a tunnel built, a VXLAN tunnel that is, from the leaves to the AVE. In that sense, the AVE becomes sort of a pseudo leaf controlled by ACI. Once we associate an EPG with that VMM domain, port groups will be pushed down to the DVS. These port groups will be private VLAN port groups, PVLAN port groups, with a primary and secondary VLAN. We'll talk about the details of that in the following section. Once we connect up our VMs, we are going to do some basic ping test, and then we are going to do some vMotion test, and we'll show you few basic CLI commands that can be used on the AVE if necessary. Though these are very basic tests, it gives you the idea on how easy it is to use AVE and the benefits of using AVE. Overview of the AVE. Cisco used to have a DVS switch, a distributed virtual switch called the AVS. The AVS used to be installed in the kernel space of ESXi. After VMware 6.5, VMware stopped giving access to the APIs on the kernel of ESXi, and because of that reason, AVS cannot be installed after ESXi 6.5. For that reason, Cisco has come up with this AVE switch. The AVE switch is a VM that is purpose-built and runs as on the user space instead of the kernel. So basically, because it is kernel independent, in theory, the AVE switch could run over different hypervisors and have the exact same functionality. Of course, at this moment, as of 2018 July, we can only run this AVE on ESXi. As you can see in this diagram, the basic principles of VMM integration with AVE has not really changed. The APIC still talks to the VMware vCenter, and the VMware DVS, or VMware DVS, is spun up, and on that DVS you have the AVE, which is the VM which is running on top of that with two interfaces, an outside interface and an inside interface, and a third interface which is used for management. So you could SSH to the switch and do your regular maintenance on the AVE, which of course is very important also. The outside interface could carry a bunch of VLANs and also the infra VLAN, which means that you could configure this as a VXLAN switch only, or a combination of VXLAN and VLAN. The inside interface is a promiscuous trunk, and the port groups on the VMware DVS is where the VMs connect to, and those port groups are then connected through the DVS switch to the inside interface, and that inside interface connects to the AVE, and then the outside interface goes to the infra VLAN. Now, you might think that because the AVE runs in the user space instead of the kernel, there would be some implication for performance. However, AVE uses the DPDK architecture, and because of that, it has been purpose-built and is very efficient in packet forwarding. So from a performance perspective, there is really not a lot of difference. In addition, because of a consistent interface, the AVE turns out to be a better option than the previous AVS. When you run the AVE, a VMware DVS or VDS is brought up, and the interfaces over there, the main interfaces that connect to the AVE, are configured as private VLANs, and AVE receives on the secondary PVLAN and forwards on the primary VLAN. It supports VXLAN and VLAN, and for vMotion, flow state will be synchronized across AVE. This diagram shows when packets are going out from the VM, they come from the VM and they go on the secondary VLAN. So if you look at any of these interfaces, they are PVLANs, and they have a primary and a secondary VLAN, and the VM sends out on the secondary. Similarly, when packets are coming in, they come from the outside top of rack switch to the DVS through the VM NIC, and then they go to the AVE, and then from there they are sent out on the primary VLAN to the VM. The connectivity from the VM NIC from the leaf to the AVE for these packets come over a tunnel, which is a VXLAN tunnel. So there is a VTAP which is installed on the AVE. Actually, there are a couple of VTAPs, but we'll talk about that in more details later. Now, there are times when you might want to bypass the AVE and come in direct VLAN and reach a VM. A perfect example would be if you needed to use a storage adapter on a VM for NFS or something like that. Obviously, you might have a question in your mind, is that if I already have a DVS which got pushed down by the APIC, and then I'm putting the AVE VM on it, why do I need to even do that? Why can't I just use the DVS and hook up all my VMs directly to it? You might also think that because you have to go through the AVE instead of going directly, there would be a lot of performance impact. To answer that question, we've discussed how we use the DPDK to build this VM, and you can do a search on DPDK if you are not familiar with it, and you'll see that it is a set of data plane libraries and network interface controller drivers for fast packet processing. So Cisco has done a lot to make sure that the performance does not suffer by not putting the AVE on the kernel and by putting it on the user space. These are some of the roadmaps of the ACI Virtual Edge on the AVE. Right now we are on release 3.2. That's what we will use in this demo. And basically we have a lot of features over here that you can see. VXLAN, microsegmentation, distributed firewall, guided install, and then of course we have the remote physical leaf support, remote storage support, and then full switching and local gateway are coming, local endpoint policy enforcement, and then in-service upgrade and titration sensors. What about the use cases? AVE use cases simplify fabric interconnect and blade switch deployment. So fewer VLANs to keep track of, because we are encapsulating everything over VXLAN and there is a tunnel from the leaf to the AVE switch. So you only need one VLAN on the outside, and then on the inside you have a bunch of primary and secondary PVLANs which are never seen on the outside. So for all practical purposes, on the inside you could be using the same VLANs on every one of the hypervisors. It also gives you good scalability. A big problem that's often seen in many of these uh, switches is that they have many blades. In a blade switch, they have many blades, and they have a lot of VM NICs, or PNICs as they call it, and then uh, people want any VM anywhere, any VLAN anywhere, and because of that reason they pass all the VLANs down these PNICs. As an example, let's say you had UCSB with 2 fabric interconnects and 10 chassis, each chassis having 8 blades, that's 80 blades, and there are 6 PNICs that go to each of the blades, that's 6 times 480, times 100 VLANs, that gives you 28,800 PV count. A lot of devices cannot even scale up to that kind of scale. So as you can see, when you have blade chassis with many chassis and many blades and many VLANs and many PNICs per blade, you can easily run into a scale issue. This can happen in other chassis other than UCSB because every device has some sort of limitation on that. The second point I want to bring up is the investment protection. So if you already had a classic network running, let's say with distribution access layer, and you extend the distribution to ACI, the VLANs from distribution to ACI for migration purposes, which is normally the way you would do it. And if you had hypervisors behind the 5Ks, initially with this AVE, you could just pass your infra VLAN. Generally, you would choose 3967 and let that infra VLAN plummet all the way to the hypervisor on a separate pair of VNICs, and you can then bring up the AVE switch over there, and then you could map your EPGs to the VLANs, and you could use VMware Wizard to switch over from the previous DVS port group to the AVE port group. And then with more steps, you could later on bring those switches directly to the leaf, directly connected to the leaf at a later time. So this is very helpful during migration. It gives you complete visibility of the virtual workload, microsegmentation, distributed firewall, first-stop security features, span, span, and easy migration. Let's talk about what you need to install the AVE. So to install the AVE, you can use vSUM from VMware, the VMware vSphere Update Manager, or you can do it manually, of course, one by one, but that would be kind of tedious to do, especially if you have a lot of hypervisors. The easy way to do this is to use the ACI plugin on vCenter. The ACI plugin is a plugin that you can download from CCO, and you then install it in a particular way, and you basically get an icon, an ACI icon in vCenter. And from there, you can configure a tenant in ACI or do other things with it. In this particular case, we are really not going to be interested in doing all that. The main purpose for us is to use this plugin to install AVE on different hypervisors. It makes it very easy. So why use vCenter plugin to do this? So basically you take the OVF file and you put it in the content library of vCenter. vCenter 6.0 and higher has this thing called the content library where you can put in the OVF files and then deploy them. And then you use the vCenter plugin to go ahead and push them to all the different hypervisors. And of course, one thing to mention here is that the AVE is basically a virtual switch. So you probably don't want it to be moving around doing DRS. Getting a VM ready to install vCenter plugin. So in this demo, I'm going to actually show you how to install the vCenter plugin. You can find documentations on that, but over here we'll do a step-by-step install, so it would help out if you were not familiar with it. The topology we will use is very simple. We have two leaves, leaf 303 and leaf 304, and they are connected one arm to a hypervisor each. I purposely have not done two arm because I want them separate. Of course, in production, you would do a VPC and you would do two VM NICs going from each hypervisor, one to each switch. One of the requirements for this plugin, to install the plugin, is that you have to have a VM from where you have to run a Python script. However, the version of Python needs to be higher than 275 or 279 actually. So if you install CentOS or something like that, then the operating system comes with a version of Python which is 275. So you would have to upgrade that. Now when you download this vCenter plugin, there is a README file where all the instructions are there on the requirements and how to run the Python script. However, you need to know how to upgrade Python on a VM for you to be able to do this. The thing about upgrading is that you want to be very careful because you don't want to destroy or override the Python version that comes with the operating system, because if you did, the OS will not work properly anymore and all your YUM modules would fail. Briefly, these are the steps that you would need to do, and we are actually going to do this in the next module. So we'll have to install CentOS and then download the plugin for the APIC from CCO. Make sure to read the README file, upgrade the Python version, and you can go to that website over there. It has very good instructions on how to do it. And then you install pip and install basic web server and make sure that you have HTTPS services running over there. So you put in a self-signed certificate. Then there is a parameter file called deploy.cfg, which you modify with the certificate thumbprint and also the VMware IP address, username, password, and the VM's, some information from the VM. And then then you deploy that script, and it should push the package to the vCenter, and then the vCenter should have an icon with ACI on it. And then as an extra bonus, we are also going to install a NFS server on that VM. The reason being is that you have to take the OVF file from CCO and push it down to a library in vCenter, like we talked about a little while ago. Now this library needs a backup, a backing for storage. Now you could put it on a particular VM's local storage, but it's best to put that on a shared storage so you can get to that library from every hypervisor, because you load that NFS storage from every hypervisor that you were going to upgrade. This would make it much easier to do the installation. Thank you for watching the overview of AVE. Please move on to the next topic, which will discuss and do a demo step by step on how to prepare a CentOS VM so it can be used to install the ACI plugin on vCenter. Last minute addition. Due to people asking for this, we have included Section 3. In Section 3, we are going to demonstrate microsegmentation with AVE for both VXLAN-based EPG and VLAN-based EPG. Now, please move on to the next module of this training.